Hello and welcome to Unit 7, Part 2. My name is Mr. Bell, and today we're going to talk about taking square roots and simplifying radicals. When asked to simplify radicals, basically what you're trying to do is to make sure there are no perfect square factors left underneath the radical. And just to kind of refresh you on the perfect squares, they are 1 times 1 is 1, 2 times 2 is 4, 3 will make 9, 4, 16, 5 squared, 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. Now there's lots more, but this should serve our purpose pretty well for now. So if we're looking at the square root of 49, it happens to already be a perfect square. So think to yourself, what number times itself gives you 49? The square root of 49 is 7, but you also have to remember that when you take this square root, sometimes there are plus and minus answers in this particular case. Let's think about 7 squared. Hey, that's 49, so that works, but also negative 7 squared. Negative 7 times negative 7 is also a positive 49. So in this case, the square root of 49 is plus 7 or minus 7. Example over here to the right says square root of 60. Now, if you tried to type that in your calculator, it would give you a decimal number. So we're going to try to break 60 down and see if there are any perfect square factors in there. Now, what I like to do is sort of use division. Think about the biggest perfect square that can go into 60. Well, you know 64 is too big. 49 doesn't go into it evenly. 36 doesn't. 25 doesn't. 16 doesn't. 9 doesn't. 4 does go into 60. How many times? 4, the square root of 60 actually breaks down into the square root of 4 times the square root of 15, right? Because 15 times 4 is 60. I can't take the square root of 15, but I can take the square root of 4. The square root of 4 is 2, and I'll just bring down my square root of 15. So this is a simplified expression to represent the square root of 60, and it's simplified because it doesn't have any perfect square factors on the inside. Let's try another example. We're looking for the square root of 50. It's not a perfect square, and I don't want a decimal number. I need to simplify it. So let's look and see if there's any perfect square factors that 50 can be broken down into. Let's start with the largest possible one. 49 does not go into 50, nor does 36. 25 does go into 50. The square root of 50 can be broken down into the square root of 25 times the square root of 2, because 25 times 2 is 50. Now I can't take the square root of 2, but I can take the square root of 25. Recall that it is 5. So after I take that square root, I'm going to bring down the root 2. 5 times the square root of 2 will give you the same decimal number as the simplified version of the square root of 50. Square root expressions can be added or subtracted if they have the same number underneath the radical once it's simplified. Sort of the same way you combine 2x plus 5x, because they both have an x, they're considered like terms. But the key to this is they need to be simplified first. So the square root of 27, let's see if we can break down square root of 27. 25 doesn't go into it, 16 doesn't go into it, 9 does though. The square root of 27 can be broken down into the square root of 9 times the square root of 3, because 9 times 3 is 27. And I can actually take the square root of 9. This actually simplifies to 3 root 3. The next expression, the next term, 2 times root 3, cannot be simplified anymore. So I'm going to bring it down, 2 times root 3. Then we have minus the square root of 12. The square root of 12 can be broken down into the square root of 4 times the square root of 3. And we can take the square root of 4, it is 2, and bring down the root 3. So now that they've all been simplified, if you'll notice, each term has the same radical. They all have a root 3, so they are like terms. We can combine these. We're going to take 3 root 3's, add 2 root 3's to give me 5 root 3's, and then as my last step, I'm going to finish out by subtracting 2 root 3's. Same way that 5x minus 2x leaves you with 3x, 5 root 3 minus 2 root 3 leaves me with 3 root 3 as my simplified answer. On this example, you're asked to simplify a cube root expression with variables. Now, just kind of a refresher, remember when we found the square root of a number, like the square root of 16? We're looking for what number times itself gives you 16, which one of them was 4 and 4. There's an understood 2 for square root that doesn't get written, but you're looking for a set of 2 factors that are the same value that give you 16. Keep that in mind when we're finding the cube root. The cube root, we're looking for a set of 3 factors that are all the same number. For instance, 2 times 2 times 2 will give me 8. So the cube root of 8 is 2. In this case, we're asked to find the cube root of 27. So let's see if we can break down 27. 27 breaks down into 3 times 3 times 3, right? 3 times 3 is 9. 9 times 3 is 27. And I'm going to write all the letters out as well, all the variables, so that you can kind of get an idea how this works. X to the third power means that there are 3 x's. Y to the second means there are 2 y's. And there are 7 z's. 1, 2, 3, 4, 5, 6, and a 7th one. So now what I'm going to do, since this is a cube root function, is I'm looking for any sets of 3, and then I'm going to pull one value out of the function. So here is a set of 3. I'm going to pull one of those to the outside. There is a set of 3 x's, so I'm going to pull one of those to the outside. There's only 2 y's, so those are going to stay inside of the radical. And now I'm looking for sets of 3 z's. There's 1 set, 2 sets, and the one left over, there's not enough to form a set of 3, so it stays on the inside. And as my last step, I'm going to kind of simplify this. This is 3x. Having 2 z's means z squared. And then I'm going to leave my cube root function with y to the second and a z left on the inside. So basically, whatever the index is, whatever the root is, we're looking for that many in a set that are factors inside the radical, and I'm going to pull those to the outside if I possibly can. All right, thanks for watching, and hope this helped.